Hi students, today I am going to discussing application number 9. See, so this one is application based on the work done. Once see the application what is given in the a body of mass is there. The body of mass is given here small m, and this body of mass is moving upward, nothing but moved up. This moving up on smooth inclined plane. This inclined plane making an angle theta with horizontal, and the inclined length is given here capital L. So when the body is moving upward on inclined plane, we are applying a constant horizontal force is capital F. So what is the main importance of this application means we need to find out the work done by the resultant force. Work done by the resultant force. According to this question, this application, I am going to draw the diagram. Please observe it. This is the inclined plane I am taking. Right. This is the inclined plane. On this inclined plane, I am taking one block. This is the block, and this block mass is m, and length of this inclined plane is a capital L. Okay, and this one is making theta with horizontal. Theta with horizontally. Okay, this is the diagram. Now on this diagram, what we are doing in this case, we are applying the force, horizontal force we are applying in this case. Horizontal force means how, for example, I am taking from the center point, we are applying the force will be like this, horizontal force. So horizontal force is given capital F. Next, this the body means the weight also is acting. The weight of the body is always acting in this case vertically downward. This is the weight. W is equal to here mass into a gravity theta. Now again one more force also is acting. That force we called as here normal force. So normal force is always perpendicular to the inclined plane. In this case, this is the inclined plane, perpendicular to the inclined plane in this case. Okay. So these are the forces acting on this block, right? Now weight is a one type of the force. So this is the force means is a vector quantity. The vector quantity has the components in this case. This weight is resolving into two components mainly. One is the cos theta, second one is sin theta, mg cos theta and mg sin theta. Then which one is the theta in this case? And one more thing in this case, weight is always between the two components. The other two components always is perpendicular, and this weight is between those two components. If you see in this diagram, I took the two components, this white color things. Wow, okay. But these two components, which one is the cos theta and which one is the sin theta, how to find means once we can see the application number 8 very clearly, then you will understand the what is the theta value, where theta it will come. So according to this diagram, if suppose this is the theta inclined with the horizontal means now this is the theta in this case. So where theta is making that we call as that component we call as in this case mg cos theta, and other one we call as in this case mg sin theta. This mg sin theta is a parallel to the inclined plane. Now mg is over. Now I will take the horizontal force in this case. Again horizontal force also is a vector quantity. Again this is also resultant force means again two components are there. Again these two components is a perpendicular, and these two components between this force should be there. Now we can see I am drawing this red color. This is the one component, and second component is coinciding with the mg cos theta in this case. These are the two components. Okay, right now. Then which component is cos theta and which component is sin theta, that is the point in this case. Okay, now we can see. So this side we are getting the theta in this case, means this is we called as here mg cos theta, and this is the mg sin theta in this case. So when you apply the force on this block in this case, the block is moving up on the inclined plane, moved up on the inclined plane. It is not moving like a normal direction side and mg cos theta side, it is not moving in this case. Okay, so means in this case, if you see this is the inclined plane direction, means nothing but x-axis like inclined plane. This is we called as in this case y-axis. Okay, this is the negative x-axis and this is the positive x-axis, positive y-axis, and this is the negative x-axis. This x-axis is like a inclined plane, so the block is moving in this case along the positive x-axis directions. Now I will take the formula in this case. Work done, W is equal to, formula is force into displacement in this case. Yeah, this force is nothing but net force, nothing but total force in this case. So total force, how much is acting, means in this case F net is equal to here F1 plus F2. So here F1 is nothing but I will take F cos theta. Sorry, not F. Sorry, Amma. I think I did the small mistake in the diagram. Can you please check it? This is not mg because this is the force, right? Force, right? So that's why this is the F cos theta and this is the F sin theta. Now please keep it mind, F cos theta and F sin theta. This is not mg in this case. I am arranging this one. Okay, this is we called as here F cos theta and this is the F sin theta. Okay, right now this f1 is equal to f cos theta and plus f2 is nothing but in this case minus mg sin theta, mg sin theta. Where this one is came means in this case, so this is the one force and this is the another force in this case, both are opposite directions. So which side the body is moving, that one I took the positive, that's why f cos theta is the positive and mg sin theta is the negative in this case. So finally f net is equal to here f cos theta minus mg sin theta. This is the net force. This net force formula, net force equation, you please substitute in the work formula. Then W is equal to F net is nothing but here F cos theta minus mg sin theta. Here S is nothing but distance. Distance of the inclined plane is given L. So this is the work done by the resultant force on the body in this case. W is equal to F cos theta minus mg sin theta into L in this case. Clear? Right. So maybe some people maybe get doubt, sir, why you took the theta here and why you got F cos theta and F sin theta in this case. Okay. Now we can see this is the theta in this case. Here we can observe very carefully in this case. This is the, I'm taking the side and this is the right, and this is the force is the F, and I want to find out this one. You can see this is also, and this is the mg in this case. Okay, this is the mg and this is the mg cos theta and this is the mg sin theta. Now we can see this is the theta, that is the theta in this case. So this total angle is how much in this case? 90 degrees in this case, and this is also 90 minus theta. This is okay, this total angle is the 90. So this angle is come 90 minus theta here, and this is will come the theta here also. Okay, this one I did in the application number 8. Once you have to cross check it, that is okay, then you will get the idea about this theta in this case. Okay, thank you so much.